In this video, we're going to discuss regression equations. On the Regent, you might be given a table with x and y values or a graph with points and be asked to write the equation of either a line or a quadratic function, a parabola, or an exponential function that passes through them. Generally, these will not be exact values that will form an exact line or a quadratic function that will form an exact parabola. You'll be asked to find the line of best fit or the curve of best fit, and we're going to do this using the calculator. Let's start with a linear regression model. Let's say you're given the table. You can see that this is going to be a linear model because there's a relatively even rate of change between each of the consecutive points. The rate of change is about 2 or 3 between each point. To write the linear regression equation for these points, we're going to press the Stat button, Edit. We're going to enter our x values into L1 and our y values into L2. Then we're going to press the Stat button, right arrow to Calc, and we're going to scroll down to 8, where it says Lin Reg for linear regression. We're going to press Enter. Our x list, the list of our x values is in L1. Our y list, our list of our y values is in L2. That's correct. Frequency list, we don't have one. Store regression equation, we could either type in y1, y2, y3. We could type in whatever y equals value that we want so that it will transfer the equation over to graph it. So let's put this into y1. So we're going to press alpha, trace. So we're in F4, and we're going to click Enter over y1. Now we're going to scroll down to Calculate and press Enter. And the calculator calculates for us this equation. Y is equal to a plus bx, where a is, let's round it off to the hundredth, a is 2.48 and b is 2.80. So y is equal to 2.48 plus 2.80x. Now if we press the second stat plot button and we press Enter by 1, we could graph these x and y points. Then we could look at the line that was graphed for us. So to graph this, we're going to turn plot 1 on, press Enter over the on. Type, we want to make this into a scatter plot because we have x and y points, so we're going to click over that. Our x list is in L1, that's correct. Our y list is in L2, that's correct. The mark could be that box, and the color blue, that's okay. Then we're going to press Zoom 9 for Zoom Statistics. Those are the points. And that's the line of best fit. That's the closest line to each of the points. It passes through some of the points and it's very close to the rest of the points. Let's try a quadratic regression now. Let's say we're given a table of values. So to graph these points, we're going to press Stat, Enter over Edit, and we're going to type the x values into L1 and the y values into L2. Let's first look at how these points look, and then we'll calculate the regression equation. To graph these points, we're going to press second y equals, so we click on Stat Plot. We're going to press Enter over plot 1. We're going to turn it on. The type is a scatter plot. Our x list is L1, our y list is L2. The mark is okay, we can leave it as a box, and the color could be blue. We're going to press Zoom 9 for Zoom Statistics. And you can see that the points are arranged in the shape of a parabola, so we know that we're going to use a quadratic regression equation. To calculate the regression equation, we're going to press Stat, right arrow to Calc, scroll down to 5, quadratic regression, press Enter. Our x list is L1, our y list is L2, frequency list we don't have one, store regression equation, we're going to store it in y1. So we're going to press alpha, trace, so we click on F4, and we're going to press Enter over y1, and then we're going to press Calculate. By typing in the y1 by store regression equation, we're storing whatever equation the calculator calculates in y1 so that it will graph the equation over the points. Let's press Enter to calculate the equation. That's the equation. Let's round it off. So y is equal to, let's round to the hundredths, 0.88 x squared plus 2.31x minus 1.31. That would be the quadratic regression equation. Let's see how it looks when it's graphed. We're going to press Graph. And since we already had the calculator put the equation into y1, when we press graph, it automatically graphs for us over the points. We can see that's a relatively good fit for the points. Next, let's look at an exponential regression equation. Let's say we're given a table of x, y values, and we're asked to determine the exponential regression equation. We know that this is going to be an exponential regression equation because the rate of change is not a constant. We're multiplying each y value by something for each change in x. Let's graph the points and see how they look, and we'll see that they look like they're going to form an exponential equation. We're going to press Stat, Edit. We're going to put our x values into L1 and our y values into L2. Let's graph these points to see if they look like they would form an exponential equation. We're going to press second y equals to press on the stat plot. We're going to press enter over plot 1, turn it on, and the type is going to be a scatter plot. Our x list is L1, our y list is L2. Our mark is going to be that box, and the color blue. Then we're going to press zoom 9 for zoom stat or zoom statistics. And we see that it forms something that would look like an exponential equation. Now to actually calculate the exponential regression equation, we're going to press stat, right arrow to calc, scroll down, EXPREG, exponential regression, and press enter. Our x list is L1, our y list is L2. We don't have a frequency. Let's store the regression equation in y1 so that when we press graph, we'll be able to see the curve also. By pressing alpha trace for F4, we could click on y1, and then it automatically transfers the equation over to y1. Then we're going to scroll down and press calculate. The exponential regression equation, let's round it off. Y is equal to, A is 3.65 times 4.64 to the x. That would be the exponential regression equation. And now we're going to see how it actually looks graphed. The calculator automatically transferred it to y1 for us, so we could just press graph and we'll see it graphed over the points. It's a pretty good fit for the data. It passes through most of the points. On the calculator, you might also be asked if you're given some points that look like this. Of course, you'll be able to see the exact coordinates. You'll have to be able to tell when to use a linear equation, like for that graph, when to use a quadratic equation, when the points look like that, and when to use an exponential equation when the points look like that. Once you have your linear regression equation, your quadratic regression equation, or your exponential regression equation, you could use that to find values that weren't already given to you in the table. So let's say we wanted to use this exponential regression equation to find what would be the y value at x is equal to 6. So all we have to do is plug in x is equal to 6. So we would do y is equal to 3.65 times 4.64 to the x, which is 6. And then we could do it on the calculator. 3.65 times 4.64 to the x, which is 6, and enter. And that would be y is equal to 36425.10. We'll round it off. And we could do this when we have a linear regression equation or quadratic regression equation or an exponential regression equation.